dark matter versus emergent gravity, the new theory about what exactly can explain the different areas in our universe that has a very strong gravitational pull, but we have not been able to actually observe. So dark matter, if any of you guys remember, maybe from Astronomy 101 in high school or in college, dark matter was served as the only explanation as to what filled up the empty spaces in our universe other than dark energy, as opposed to the areas that we have been able to observe. Theoretical physicists took a few measurements and they found that about 4% in the universe that is made up of regular matter. And what I mean by regular matter is planets, stars, just different debris, gas clouds, nebulae, all that fun stuff. And what we found is that in the cosmic microwave background, which is just the scale of our universe, we found a lot of areas that seem to be dark. And so up until recently, theoretical physicists said that it was dark matter and dark energy. They saw that about 23% of it was made up of dark matter and about 73% of it was made up of dark energy. But we're not going to get into that right now because we found something that we believe is emergent gravity, which is based off of temperature. Now let me explain a little bit about what we thought dark matter was. The way we were able to observe it was because we would see nearby objects or stars. When we would measure them, it would look sort of distorted. Say that this is the source of where the light is coming from, and this is maybe a planet that's between the star and us, or as we thought was dark matter, that would be between the source of where the light's coming from and us. It would cause it to bend. And this odd way of observing the bending of light or the distortion of light is just called gravitational lensing. But then now this brings me into why galaxies, when they're rotating, they seem to be spinning faster towards the outer regions as opposed to the center. You have the arms of the galaxy right here, and then you have the center, and the center is generally a black hole. So why is it that this area, which should be spinning faster because with a black hole you have a really strong amount of gravity, it's not actually the case? We're finding that the outer regions are actually spinning faster than the center. What we thought it was due to dark matter. Recently we found out that this could actually be due to heat and thermal activity. And the reason that we called dark matter just because it doesn't emit any light. This heat that was being emitted from this possible energy source that is in our universe can really be the explanation as to the strange phenomena that we observe in galaxies. We have atoms that are inside of the star, just like my earrings actually here. Let's say you have two hydrogen atoms and they are like getting really close to one another, but you're having a repulsive force, you're having an opposition force, and this is because of the electrons that are orbiting the nucleus. You have those that are pushing against each other. This is called electron degeneracy pressure. That's because you have the pressure of the electrons that are not wanting to fuse with one another. However, eventually this pressure gives and then they collapse into one another, and this would be called just electron capture, just because the protons are capturing the electrons. So it's kind of funny. We now find that it could be due to this entropy, this heat, this release of heat from the opposing force, the positive force in our universe. And it can be the reason that's causing it to be rotating. Just take this as the scale of our universe, just hypothetically. This is what we had thought originally was dark matter. We saw that this was like pulling in because it has a gravitational force. This is what we saw as dark energy, which had an opposing force so that the universe doesn't collapse in on itself. But now with this theory of emergent gravity, this is what we see it as the heat that is being released from this dark energy, because we find that over 73% of the universe is this dark energy. That there is now this heat, this temperature that is causing this gravitational pull on different objects in our universe. So that is probably the best way I can explain it, because I'm not too familiar with the new theory. I'm going to try and read up some more on it, and this MIT course was excellent. And that about wraps it up, and next time I'll talk to you guys will be next week. I'll try and do a video just before I head over to Washington, D.C. I will talk to you guys next time. Thank you so much. Bye, guys.